Find the equation for x as a function of a and b, which will maximize angle theta. In this problem, points P1, P2, and P3 make up a triangle, where angle theta is the same as angle P3, P1, P2. A practical application of this problem is to pretend length A is the height of a painting, and the line containing line segment P3, P4 defines a vertical wall on which the painting hangs. And the eyeball of an observer is positioned at point P1, which is a horizontal distance x away from the wall, and a distance b below the bottom of the painting. In this problem, maximizing the angle theta will generate the same equation for x as maximizing the tangent of angle theta. If the value of x is very small, then theta is also very small, like sitting in the front row of a movie theater. And if x is very large, then theta is again very small. So we want to find the optimal distance x, which will maximize the angle theta, so that x isn't too close or too far from the wall. We can find this value of x by developing an equation for the tangent of theta as a function of the distance, x, taking the derivative of that function with respect to x, and solving for x when that function equals 0. To develop an equation for the tangent of theta, we'll define angles theta 1 and theta 2 as angles P3, P1, P4, and P2, P1, P4, respectively. And then the angle theta equals theta 1 minus theta 2, where theta 2 equals the arctangent of b divided by x, and theta 1 equals the arctangent of the quantity a plus b divided by x. After making the substitutions, theta equals the difference of two arctangent values. From trigonometry, we recall the arctangent of p minus q equals the tangent of p minus the tangent of q divided by the quantity 1 plus the tangent of p times the tangent of q. If we assign the variables p and q to theta 1 and theta 2 respectively, then the tangent of theta equals a function of the operators tangent and arctangent and a function of the variables a, b, and x. Thankfully, the tangent and arctangent terms cancel out, and our equation for the tangent of theta simplifies to a quotient composed of variables a, b, and x. Further simplifying the equation, the tangent of theta equals a times x divided by the quantity x squared plus a times b plus b squared. Since we want to find the distance x from the vertical wall that the tangent of theta remains constant with respect to x, we'll take the derivative of the tangent of theta and set the value equal to 0. Using the quotient rule for derivatives, we'll assign the variables p and q to the numerator and denominator in our equation for the tangent of theta. After taking the derivative with respect to x, we'll set the right-hand side of the equation equal to 0 and solve for x as a function of a and b using algebra. After dropping the denominator, isolating the x term, simplifying the left-hand side of the equation, dividing by negative a, and taking the square root, we find the value of x equals the square root of the quantity a times b plus b squared. At this distance, the angle of the picture subtended by the observer's position will be maximized. When reviewing the possible solutions, the answer is B.